Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 5.2, Relations and Functions. We're going to review some terms. The domain is the input or the x values. The range is then the output or the y values. A relation is a set of ordered pairs. A relation can also be represented by a table, a graph, or an equation. All right? So function is a relation that assigns exactly one output value for each input value. Now, you might be wondering what that means. You're going to see here in a second. A relation is a function if each element in the domain is used only once, but the elements in the range can be used more than once. All right, we'll see what that means here in 1 second. Oops, hang on. All right, making a mapping of each relation, then tell if the relation is a function. To make a mapping, make a table of values, but spread it out. All right, so what we're going to do is we're going to take each one of these first numbers and put it in for underneath the domain. So I'm going to have 3, 9, 2, and 4. Then I'm going to take each one of the second numbers and put it in for the range. So it would be 4, -3, 1, and 3. Okay? So what we need to do to figure out if I have a function or not is to see, did any of my domain values repeat? I do not have any of my domain values repeating. None of my range values repeated. Even if they did repeat, that wouldn't be a big deal. But since none of these repeated, it is a function. All right, we're going to do the same thing in B. So I have 1, 7, 5, and 7. I have -2, -7, 3, and 3. What I need to check first is the domains. Did any of them repeat? The 7s did in fact repeat. Now that I saw that the 7s repeated, I'm going to check the values in their ranges. If they are different, like this case here where I have a -7 for the first 7 and a +3 for the second 7, then this will not be a function. It's not a function. If for some reason this 3, don't erase this, just pay attention. If for some reason this 3 was actually a -7, that means it's the same point, so then it would still be a function. All right, so this is not a function because where the x values repeated, the y values did not repeat. So on to C. We need to do the same thing again. I have 1, 2, 2, and 3. I have 4, 5, 5, and 6. In this case, I have these 2's that did repeat. However, they really are the same points because their ranges also repeated, which means that if I were to graph this, I have a point 2, 2, 5, and I have another point 2, 5. It's exactly the same point, so that is not going to affect whether it is a function or not. So this is a function. Can we determine functionality without a mapping? Yes, we can. We just need to make sure all x values only have one y value. What this is asking us is, can we just figure out from that right there whether or not we have a function or not? We could. We don't need to necessarily make it into a table like that. And you'll be able to do that a lot easier the more problems you work through. Okay? On to the back. The vertical line test. This is talking about graphs. A graph is a function if a vertical line hits the graph only once. Whoops, misspelled once. Only once. This is called the pencil test. We'll use the pencil test to figure this out. All right. So what we're going to do is, I can't really show you the pencil test up here during the video because you can't see me holding my pencil. But if you hold your pencil straight up and down and put it flat on the paper and drag it across, does your pencil hit more than 1 point here? No, it doesn't. There's only 1 point there. So far so good. It is a function. Does it hit more than 1 point here? Since it does hit more than 1 point there, there are 2 points on the same vertical line, then this is not a function. And you do not have to continue with the vertical line test. Okay? On to the next one. I'd have a vertical line at this point. It only touches once. I'd have a vertical line at this point. It only touches once. Remember, you don't need to be writing these lines. You should just be taking your pencil and dragging it straight across the graph. At this line, it only touches once. This line only touches once. This line, and this line. So they only touch once every single time, which means that my pencil would only have been touching 1 point at any given point, at any given time. So yes, this is a function. And I'll try to show you the vertical line test tomorrow a little bit better if you're struggling with it a little bit. All right. Evaluating functions. It is just equal substitution. Do not get lost in the notation. Just substitute. So this says in our table, it says the domain, the input is the x. The output could be f of x, which it tells you that's how you read it here. F of x, which is really just the same thing as y. It means f of x. So let's look at this little box here. The x just tells you what number to substitute. Leave the f of x alone. So if we have the example is f of x is equal to x minus 5 if x equals 3. So I'm going to take the 3 and plug it in for both the x's. So you notice that now it is f of 3 is equal to 3 minus 5. I'm not going to do anything at all with that f of 3. I'm just going to continuously write f of 3, f of 3, f of 3. It really means the same thing as y. But on this side, I have 3 minus 5, so I go ahead and evaluate that for -2. All right? So example 3, we need to make a table for each function. Use 1, 2, 3, and 4 for the domain. So that means I'm going to take 1, plug it in for all the x's. So I'd have f of 1 is equal to 1 minus 5. So f of 1 is equal to -4. Put -4 in for f of x. Now I'm going to take 2 and plug it in for all the x's. I would have f of 2 is equal to 2 minus 5. So f of 2 is equal to -3. I'm going to put 3 in for all the x's. F of 3 is equal to 3 minus 5. So f of 3 is equal to -2. And then f of 4 is equal to 4 minus 5. So f of 4 is equal to -1. And you are done at that point. I'm going to do the same thing in B. I would have f of 1 is equal to 1 squared. Well, 1 squared would just be 1. F of 2 would be equal to 2 squared. So f of 2 would be equal to 4. F of 3 would be equal to 3 squared. So f of 3 would be equal to 9. And f of 4 is equal to 4 squared. So f of 4 would be equal to 16. Okay? On to the last one. Again, I'm just going to take each one of those numbers and plug them in for x. Be careful here, though, because I have a negative x right here. So what I'm going to do is I'm going to rewrite these problems. So f of 1 would be equal to negative, parenthesis, because the negative's out front, 1 plus 6. Well, if I have a negative in front of a parenthesis, I distribute. So this is negative 1 plus 6. So f of 1 would equal 5. I'm going to do the same thing with f of 2. So f of 2 is equal to negative 2 plus 6. F of 2 is equal to 4. Same thing with 3. So f of 3 would equal positive 3. Same thing with 4. F of 4 is equal to negative parenthesis 4 plus 6. So f of 4 is equal to negative 4 plus 6. So f of 4 is equal to 2. Okay? What do these new numbers represent for each function? They represent the range or the outputs or the y values or the dependent variables. All those things just mean the exact same thing. All right, so that is the end of the lesson. The most important thing here to remember is that a function is only a function if the x values are when I have an x value, it only has one y value associated with it. When you look at a graph, if it passes the pencil test, then it is a function. If 2 points on that graph hit the pencil, then it is not a function. And that when I have f of x and it tells me that x equals something, I'm just going to substitute that number in for all of the x's. Thank you very much for watching the video. Remember, if you have any questions, bring them to me tomorrow, and have a great day.